10.4, ellipses. I don't really know what word we want to call it. I think it's ellipses. It is when you have an elongated circle. So like the rules of a circle is that you have a center point, and then the distance from the center to the outside of the circle is all equidistant. It forms a circle. An ellipsis is when one axis is elongated. So you can have a vertical ellipse or you can have a horizontal. One thing that I am going to mark out that we will not talk about is the word focus. So anytime you see the word focus, we're just not going to talk about it. So you can just cross those out. Yeah. And that. So we're just kind of look at the circle. We're not looking at the foci at all. So that is something that I omitted from this section. We're not ever going to, so anytime you see a question about a focus, you just cross through it because we're not even going to talk about it. So here are two examples. We've got a vertical and a horizontal. And this is what I would call a horizontal ellipse. It's when I'll use the word major axis is horizontal. So this distance right here, we would call that a major axis. And then the vertical length would be the minor axis. So major just means that it's longer. And then the shorter axis would be the shorter one. So this would be the minor axis. So I'll write that to the side. Minor. I don't think I spelled that right. Nope, I didn't. And we are going to cross out the word focus. Cross it out. So when you have like the formula that we've always learned, or we have been learning from the beginning. So this is the formula for a horizontal. The x is always written first. The y is written second. You have a plus sign in between. The center is at HK. The only difference is that my A value is the length of my, like the length from my center to the outside of my major axis squared. So, for instance, like we'll look at some examples, but it is the distance from my center point to my outside on the major axis. That is considered my A. And then my distance from my center point to my minor axis point is my B. So the only, I guess, two variables that are new are A and B. And A is going to be the longer length, and then B is going to be the shorter length. And we can kind of think about this like as a radius, but they're two different ones because they're different lengths. And then the vertical ellipse is similar. Remember, we can cross out the word focus. We don't need them. But now my major axis is going to be vertical and my minor axis will be horizontal. So the only difference is that the B and the A switch. They've switched. So what I want you to think about is I don't want you to get caught up in the letter A and B. I just want you to think about A is the longer axis or the major axis, and B is the shorter axis. And if you have a vertical ellipse, then your bigger number is going to go under the Y. If you have a horizontal ellipse, then the bigger number is going to go under the X. So the bigger number goes under the fraction that is like whatever kind of ellipse it is. So that's why I circled the X on the horizontal and the Y on the vertical. Now, all of these right here, we can cross out the foci. So cross that out, cross it out. We also don't need this. I would say, like, to memorize this. However, I think it's more intuitive to just look at the picture or understand it than get caught up in the H plus or minus B, H or K plus or minus A, like all of these things. I just think that they get a little confusing. So I'm just going to put confusing next to it because I don't want you to memorize it. I want you to think my center point is at HK. Then depending on if it's a horizontal or vertical, I'm going to go up, down, left, right, that many points. And it'll make more sense once we start doing some examples. These are two things. Remember that if a word problem gives you the entire length of the major axis, then you're going to have to cut it in half. Because A only represents the distance from center to outside. So like the whole, if it were giving you the whole length, then it would be double that. Same with B. All right, so let's look at some examples. Now, whenever we're given a problem like this, we do have to complete the square first and put it into vertex form. And so we want our right side of the equation to equal what number? 1, right? And there's really nothing to complete the square on because I just have an x squared and a y squared term. So how could I make this equation look like vertex form? I could just divide everything by 100, right? So I'm going to divide this by 100, 100, 100. I'm going to do it to all three. And so 4 divided by 100 is what? 25, or I guess 100 divided by 4, plus y squared over 4 equals 1. Now, which number is bigger, 25 or 4? 25, and it's under the x, so that means it's a what kind of ellipse? Horizontal or vertical? Horizontal, good. So my center is at HK, and in this case, there's nothing in the parentheses next to the x and the y. So that means that my center is where? 0, 0. Now, since it's a horizontal, I'm going to take the square roots of my denominators, and that's how many points I go out. So my A is going to be the square root of 25, which is 5. So I'm going to go out 5 to the left and 5 to the right. And then this would be my B. So the square root of 4 is 2. So I'm going to go up 2, down 2. And then we don't do C at all because that has to do with the foci. And we're not talking about foci. And then I connect my dots. Well, that was not good. So my vertices are like the big points. So it would be at negative 5, 0, and 5, 0. Those are like the vertices are the end points of the major axis. And then co-vertices are end points of the minor, like the smaller points. So those would be at what point? What ordered pairs? Perfect. And my major axis, what's the whole length? 10. My minor axis is 4. Perfect. Not too bad, right? Good. Taking out the foci is really, that was like the part that makes people confused, I feel like. Okay, this one is already in vertex form, so we don't have to do much to it. Where would my center be? -3, 2. So I'm going to plot that point here. Now, so I've got 16 and 9. Which one is bigger? So that means it's a horizontal. So that means A and B. So my A value, like the major axis, is how many? Like A equals what? 4, and B equals 3. So I'm going to go left and right 4. And I'm going to go up and down 3. And then I will connect the dots. We don't do C. So my vertices are, and I encourage you to do vertices and co-vertices last, because it's easier once you've drawn a picture. Like if you try to add the A and B and all of that first, it just doesn't make sense. So my vertices are where? Whoops, -7, 2, and 1, 2. My co-vertices are -3, what's my Y value? 5, and -3, -1. Good. So drawing the picture first will really, really help. Length of major axis, it kind of spilled into the next page. So what's the length of my major axis? I'm doubling. So 8, and minor axis was 6. Good. Okay, try number 3 on your own. So I circled the bigger number, which is 25, and it was under the Y, so that indicates that it's a vertical. So I go ahead and write A next to the 25 and B next to the 16, just so that I know. Then take the square root of those. A is 5, B is 4. My center is at -2, 5. And since it's a vertical, that means I'm going to go up and down 5, and I'll go left and right 4. Then connect the dots, label my vertices, co-vertices, and then double my A values, double my B values to get the length of the major and minor axis. So it says write the equation of the ellipse in standard form, or like what we call vertex form, given that the vertex is at 3, 6. So that is my, that's not my HK, that would be my center. So I have a vertex at 3, 6 and a co-vertex at 6, 2. Now, I'm going to encourage you to draw a picture, because if you don't, it gets a little confusing with the A, B's, and all of that. So I'm going to put a graph to the side. 1, 2, 3, 4. I think it's all in the first quadrant. So I have a vertex at 3, 6. So here, 3, 6, and a co-vertex at 6, 2. So 1, 2, 3, 4, 5, 6. Now, to find your HK, it is where they meet in the middle. So it's going to take the X value of the vertex and then the Y value of the co-vertex. So imagine like meeting in the middle. What would this center point be? 3, 3, 2. So it is where they meet in the middle, okay? And you can go ahead and draw like your other 4 points if you want, or you can stop there. I usually will stop there. But if you want, then you could go down 4 more and then left 3 and connect the dots. Could you just take the first x and the second y? Yes, you could. But if they had it switched, then like it was co-vertex and then vertex, it would be something different. So that's why I usually will draw a picture just to kind of see. But if you don't have to, you can do that as well. So I've got my HK, which is 3, 2. So I can go ahead and do x minus 3 squared over something plus y minus 2 squared over something equals 1. Now I need to figure out what my A and B are. And so what kind of ellipse is this? Vertical or horizontal? Vertical, because it says my vertex is here, my co-vertex is here. So the length of this vertical distance is longer than the length of the horizontal distance. So all I need to do to get my A and my B is just count the distance from my center to my outside. So how many points from my center, which is at 3, 2, to my outside, which is 3, 6? How many units do I go up? 4. And then going into the formula, I do what to it? I square it. And so that's 16. And does that go under the X or the Y? Good. Because it's longer vertically than it is horizontally. Because how many points from the center to the outside horizontally? So from 3 to 6. Just 3. 3 squared is 9, and 9 goes under the X. Also, the words vertex and co-vertex tell you that it's a vertical, because vertex goes with your major axis, co-vertex goes with your horizontal. So 3, 6 is my vertex, 6, 2 is my co-vertex. So that means that it would be a vertical. And so this is my final answer. Okay, the next one, it says, write the equation of an ellipse with a major axis length of 8, and then co-vertices at -3, 4 and -9, 4. So I'm going to draw my picture. Going to make it where the second quadrant is mostly showing, because that's where most of my points are. And it goes out 9 to the left and then 4 up. So I've got co-vertices at -3, 4 and -9, 4. And then a major axis length of 8. So what does this piece of information tell me? Right, so the co-vertices are horizontal, so that means that it's going to be vertical. And it gives me the whole length, so that means that half of that distance is going to be what? Like half of 8 is 4, so that means that my A is going to be 4. Now, all I have are my co-vertices. How could I get the center with looking at these two dots? The midpoint between the two. So in between, there are 6 units between -3 and -9. So the midpoint is going to be 3 away at -6, 4. So it's just halfway between my co-vertices. So my H and K are going to be at -6, 4. Now, if you want to finish this picture out, you can. You don't necessarily have to. But if it says that the major axis length is 8 and A equals 4, that means I'm going to go up 4 and down 4 to make my ellipse. That was ugly. So this is 4. Might use a different color so you can see it. So this length is 4. And then my minor axis, or the distance from the center to the outside on my minor axis is what? The distance from like my center to my outside. 3. Well, it would be the same distance to the left as well. So even if you went to the left, this would also be 3. So now I'm going to just fill in my equation. So x plus 6 squared. And then over something. I usually fill that in last. Plus y minus 4 squared over something equals 1. Now, you guys told me that it was a vertical, and so vertical means that the bigger number is going to go under which? Under the y. The bigger number is 4, and 4 squared is? The smaller number is 3. 3 squared is? Good. So these are a little bit more lengthy. They're like more detailed, I guess, but I like these problems. I think they're good. Okay, now we're given an equation, number 6. So first of all, let's just draw some dots at our vertices and co-vertices. I'm just going to label them. There we go. Okay, so let's name the ordered pairs. We've got 2, 4, 8, negative 1, 2, negative 6, and negative 4, negative 1. So what I want you to do is try to find the equation. First, you'll need to find the center. Then you'll need to find your A length and your B length. Then I want you to put it into the vertex form that we know. So what you'll do, like looking at this picture, the first step is you'll want to find the center of it. So where do they all meet in the middle? Then you'll decide from the center to the outside, how many units is that? And then which one is longer, the vertical one or the horizontal? And that depends on what kind of ellipse it is. So try finding the equation just based off this picture. Okay, so where did we find our center point? 2, negative 1. And then the distance from the center to that top point is what? 5. And then the distance from the center to the point on the right or the point on the left, it doesn't matter, is what? 6. So it's bigger horizontally, so it's a horizontal ellipse. We've got 5 and we've got 6. So I'm going to put, so the center is at 2, negative 1. A is 6, B is 5. So I've got x minus 2 squared over something plus y plus 1 squared over something equals 1. The bigger number goes under the x or the y? X. So 6 squared is 36. 5 squared. And then I am done. So questions about that? All right, the last ones, and I want you to do these on your own, and then I'm going to put the answers on the board. Just some extra practice with completing the square. So now that we know standard form and vertex form, we maybe will have more of an idea of what the form should look like when we're completing the square. Yes?
How is 5? Like the length for number 6?
So I'm going from 2, -1 to 2, 4. So it's like the distance from -1 to 4. So I'm just counting the points from the center to the outside. Same here, I'm just counting the distance from the center to the outside. So I'm just looking at, like vertically, I'm just looking at the y values, and then horizontally, I'm looking at the x values and not distance. Does that kind of make sense? Okay. Okay, so try number 7, completing the square and putting it into the standard form. Okay, so looking at number 7, I just kind of took it a step further because I want us to think critically, like taking this equation and interpreting it. So completing the square, I only had to do it for the x. I did not have to do it for the y. How come? Yeah, there's nothing to complete it with. Like there is just a y squared, but there's no other y. There's no like just single y term. So that means you don't have to complete the square on it. So I get my x's together, I pull out the 4. Now, a lot of you forgot to do this on the quiz. When you pull out the 4, that also pulls out a 4 from the -8. So it now becomes minus 2x. A lot of you would put like x squared minus 8x. And then you got some big number, and that didn't work. So make sure that you are taking the 4 out of both the first and the second term. Then I add plus 4, not plus 1, because that would be doing what? Killing a puppy. So plus 1. Nobody killed puppies on the quiz. Proud of you.
Yes.
Then, right, some people haven't taken it yet. Then you get 12 on the right side. You want to divide everything by 12. And the 4 over 12 reduces to 3. So here the box that is highlighted is my final answer. From here, if I were to interpret a few things, I would know that it is a vertical ellipse because why? Because the number is bigger on the y, under the y. So my center would be at 1, 0. It is vertical because the number is bigger under the y. That means that my a value is going to be the square root of 12, and my b value is going to be the square root of 3, which wouldn't be a fun one to graph, but it still would be the answer. I wouldn't make you graph one of these, but I could make you tell me what the center A and B value are, and if it were vertical or horizontal. And then I just simplified this to be 2 square root of 3, because we always want to keep things simplified. Okay, try number 8, put it into the standard form, then the center A and B value. Okay, so it's bigger under the y, so that means it's also vertical. So my a would be square root of 6, b would be square root of 3, center at 1, 0. Try number 9, last one. Is this completing the square getting easier a little bit?
So does A always have a bigger number?
For ellipses, a is always the bigger number. So 2 more, 9 and 10. Okay, so 9, vertical, the number is bigger under the y. So a value of 3, b value of 2, center at -1, -1. And then for 10, it's horizontal because it's bigger under the x. A value is 2, b is 1. And like I said, you can put it over 1 or you don't have to include this and just know that it's 1. But I usually put it over 1 so that I know that the b value would be 1 away when I'm drawing my graph. Okay, any questions about 9 and 10?
Do we have to do ellipses extra practice?
No, just 10.4 homework that will be due on Friday.